Good morning. We are going to still be working in Module 5, but we have skipped a couple of lessons and we are moving to Lesson 15. So we did 10, we did 11, and now we are going to do 15 today. So get yourself ready to do Lesson 15. You are going to be doing, you need to watch the Eureka video first. That's always important in every lesson that we do, is that you watch that Eureka video first, and then you're going to come and do the problem application. It is a two-step problem, so I've divided my workspace into step 1, which goes with this part of the problem, and step 2, which goes with this part of the problem. All right, so you've got a two-step word problem for 15, and make sure that you do a word answer for both of those problems. Then you are going to move over to the problem set, and if you watch the video, you will not have any problem. You're actually going to be doing 4 different steps to this. You are going to do the chip model while you're doing the vertical model, and then you will also be checking. And we would also like you to include the number bond for each of these problems. So I'm going to draw the bibbidi bobbidi boo in for you, and you will need to add that to your problem as well. So you're going to be doing the bibbidi bobbidi boo for each of these problems with your number bond. So you can see that relationship between your whole and your parts. So there we have that. So you're going to be doing the number bond, the chip model, vertical model, and then you're going to be checking to make sure that your vertical model matches your number bond. All right, so a number bond for each of those, and so basically you're doing 4 different steps for each of these 3 problems, and you're going to solve by using the chip model and the place value chart, and then you're going to use your addition to solve vertically, and then you're going to be checking your work. All right, so that's those problems. Then you're coming over to D and E, same scenario. You're going to be doing the number bond for each of these problems as well, so that you can see the relationship between those problems. Also checking, and you are also going to be doing a number bond for letter E. Okay, there we go. And then we'd like you to try number 2, part A and part B. Complete the if and then statements, and then draw a number bond for each of these problems as well. Those number bonds, I know they're getting to be more complicated, but really they're the same concept as we've been doing right from the beginning of the school year. Of course, you guys are getting really close to being 3rd graders, so naturally things are going to be a little bit more complicated. So you are going to try problem A and problem B with the number bonds, and then you are going to check everything with me before you move on to your exit ticket. So you're going to work all of these problems, then you're going to come back and check with me to make sure that you're on the right track, and then you're going to do your exit ticket, which of course you know you need to send to your teacher. And as we have done in the other problems, we want you to also include your number bond for both of these problems, bibbidi bobbidi boo, and for number 2 as well. Here we go, bibbidi and bobbidi, bibbidi bobbidi and boo, so that you can see the relationship between all of those numbers. Okay, I think I might need to make that one circle a little bit bigger. They didn't give us a whole lot of space to be able to do that. Alrighty, so my friends, you are getting ready to get started. Make sure you watch the Eureka video first. Then you're going to do the word problem, which is a 2-step problem. The problem set, which is problems A through E. A through E, and you're also going to try problem number 2, doing the if and then statements, and then of course you are going to do the exit ticket and send that to your teacher. All right, so with that, I'm going to ask you to pause the video, and then we'll have you come back and we'll check and see how you did. Okay, pause the video. Are you back? All righty, so let's go ahead and get started on our first word problem. We have Catrona. She's our first person in this step 1. Catrona earned 16 more stickers than Peter. So Catrona has more stickers than Peter. Peter is going to have fewer. She earned 35 stickers. So we know exactly how much Catrona had. She had 35 stickers. We're trying to find out how many stickers did Peter earn. All right, so we are going to start with our tape model, which I am drawing right now. You're going to have to write a little bit small because we're going to be doing a 2-step problem. So I really do know about Catrona. Catrona has, oops, I didn't spell her name right. Let's try that again. I need to have an I-O-N-A, Catrona. We know that she had 35 stickers. And we know that Peter is what we're trying to figure out. We don't know how many Peter has, but we know that Catrona has 16 more than Peter. More than Peter. She has 16 more than Peter. So we know we have our whole, we have one part, and we're going to need to try and solve our second part. So I'm going to go ahead and do my number bond off to the side here. I know for sure that my whole is going to be 35 and that one of my parts is 16. I'm going to have to come up with my second part, which will tell me what Peter has. Bibbidi, bobbidi, and boo. Alrighty, so I can see quite easily that if I take 35 take away 16, I will find my missing part. So 35 take away 16 will equal my unknown or my missing part. That's the big question mark right now. I can handle that. That's not too hard. 35 take away 16. I'm going to be using new groups below. So I'm taking a close look at my whole, and I can see that I can't take 6 ones away from 5 ones, so I'm going to decompose a 10, leaving me with 2 10s. That decomposed 10 is now 10 ones. 10 ones plus 5 ones is 15 ones. 15 ones take away 6 ones is 9 ones. And 2 10s take away 1 10 is 1 10. So I know that my missing part is 19. And I know that 35 take away 16 is 19. And I can complete my bar graph as well. And now I can answer the question about how many stickers did Peter earn. Peter earned 19 stickers. Had to write kind of small to get all of that in there, but I think I can get it all in there. All right, so congratulations if you were successful on that. You will have to have a correct answer to step 1 in order to have a correct answer to step number 2. So let's go up and read the second part of what we're doing. We have a new person in this word problem who is Mary Jo. Mary Jo earned 47 stickers. How many more does Peter need? Here's Peter. How many more is he going to need? Wow, a lot of keywords here. To have the same amount as Mary Jo. Well, let's see here. Mary Jo has 47. Do we know how many Peter has? Well, of course we do. We know that Peter has 19. So I think if I'm thinking about my number bond, I think we know that Peter is going to be one of the parts, and we're going to have to find out how much more he's going to have to earn to have the same amount as Mary Jo, and we know that Mary Jo has 47. Oh, that's easy. I have a missing part. So let's go ahead and draw our Tate model. Here we go. And one thing I know for sure is I know how many Peter has. Peter has 19 because I found that out from problem number 1. And it tells me that Mary Jo has 47. This is Mary Jo. Mary Jo's a nice person, and we're trying to find out how many more will Peter need to have exactly the same amount as Mary Jo. So that's our unknown. Using our number bond, we can exactly see that if I take 47 and I take 19 away from that, that will give me how much he still needs to have. He still will need to earn in order to be able to have the same amount. So 47 take away 19 will give me my missing unknown in my Tate model and also in my number bond. All right, so this should be a pretty easy problem for me to work because I know how to subtract using regrouping my tens or decomposing a 10. So I'm going to take a close look at my whole. I know that I cannot take 9 ones away from 7 ones, so I need to decompose a 10. That's going to leave me with 3 tens. That decomposed 10 is now 10 ones. 10 ones plus 7 ones gives me 17 ones. Easy peasy. 17 ones take away 9 ones is 8 ones. This is where you need to know your 36s. And 3 tens take away 1 10 is 2 tens. So I know that Peter needs to earn 28 more stickers. If he's going to have the same amount as Mary Jo, he's going to have to earn 28 more stickers. So my missing part would be 28, and my missing part is 28, and I know that 47 take away 19 is going to be 28 because 19 plus 28 gives me 47, which is what I'm looking for. Do you see how your Tate model and your number bond are pretty much the same way of being able to represent those two concepts? They are very similar. All right, so hopefully you had a great experience with that word problem and you did a fantastic job. All right, let's go ahead then and move over to our next problem, which is, I'm going to write it vertically first. That's going to be 699 take away 210. So I know for sure that 699 is going to be my whole. 699 is my whole, and I'm taking away one of the parts. So that's easy for me to know. I'm looking for the missing part right there. Okay, let's go ahead and set this up in our, I'm going to set that up in my chip model. So I've got 600. I always have to show my whole. 100, 200, 300, 400, 500, 600, 610, 620, 630, 640, 650, 660, 670, 680, 690, 691, 692, 693, 694, 695, 696, 697, 698, 699. So 6 600s, 9 10s, and 9 1s. I always have to represent my whole in my chip model. As I start looking at what I'm going to do, it looks like I'm going to take 0 ones away from 9 ones. Well, that's easy. 9 ones take away 0 is still going to give me 9 because I did not take anything away. So everything is staying exactly as it is. 9 ones take away 0 ones is going to be 9 ones, and I did not have to decompose a 10. Now I have 9 tens take away 1 10. Well, that's a piece of cake. 9 tens take away 1 10 leaves me with 8 tens. Oh, so far this has been really easy with this one. And because I didn't have to decompose a 10, I don't have to worry about anything in my hundreds other than subtracting 2 hundreds from 6 hundreds. Here goes my 2 hundreds from 6 hundreds, gives me 4 hundreds. And so I know that the other side of my number bond is going to be 489. I know you have to write really tiny, I'm so sorry. And 489 is the difference between 699 and 210. So 489. Now I still have one more step that I need to take. I need to check to make certain that my subtraction was accurate, and I can use my number bond to help me with that. I know that if I take 210 and add it to what I got for my difference, it will take me back to my whole, because I know that 210 plus 489 will get me back to 699. Let's see if that works. 210, I'm going to add 489, just like in Bibbidi Bobbidi Boo. That's going to be easy. 9 ones and 0 ones is 9 ones. 8 ones and 8 tens and 1 10 is 9 tens. And 4 hundreds plus 2 hundreds is 600. Now look at how tricky that is. Can you see that those two match each other? My whole and my whole are the same, and my parts and my parts are the same, which relates back to our number bond. This is why we want you to do the number bond, so that when you're doing the checking, you can see exactly how that is working, that we are just using Bibbidi Bobbidi Boo to check our work. And the only reason I put it on this side is because there's more space on this side than there is on that side. I'd really rather have it over there, but so it is. Alrighty, so let's go ahead and take a look at what we have on problem B. So I know my whole is going to be 758, and one of my parts will be 387. I'm going to be looking for my missing part. So let's go ahead and set this up in our vertical form. 758 take away 387. 387. And if you can do that mentally, great. I am going to be showing it to you in the vertical form. So I'm going to be taking a very close look at my whole, but maybe I need to represent my whole over here first. Let's do that. Here we go. 100, 200, 300, 400, 500, 600, 700, 710, 720, 730, 740, 750, 751, 752, 753, 754, 755, 756, 757, 758. So I've represented 7 hundreds, 5 tens, and 8 ones. Now I can begin seeing if I have enough to be able to subtract while I'm looking for my missing part here. So 8 ones take away 7 ones. 1, 2, 3, 4, 5, 6, 7. Leaves me with 1. 1. Did not have to do any decomposing, so that's good. But look here. I've got 8 ones that 8 tens that I need to take away from 5 tens. Uh-oh, don't have enough. I'm going to have to decompose 100 and give me 10 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I've decomposed my 7 Well, I had 7. I decomposed one. Now I have 6 hundreds. And I no longer have 5 tens. I now have 15 tens, which is a good thing because I'm going to need them. 15 tens take away 8 tens. Well, let's see. 15 tens take away 8 tens gives me 7 tens, which is where my 36s come in very handy. But let's just double check that. 1, 2, 3, 4, 5, 6, 7, 8, which leaves me with, you're right, 5, 6, 7. So I'm right on the money. Now I'm coming over and I'm going to be taking 3 tens away from 6 tens. 6 tens take away 3 tens. Well, let's take those 3 tens away, or 3 hundreds away, sorry. 3 hundreds away. Wait a minute. Oh, I just saw my boo-boo. I took away 4 and I was only supposed to take away 3. I'm thinking that's not right. That leaves me with 300. So 1, 2, 3. I had to erase that and fix that. Sorry if that confused you. So now that I am looking, I can see that I have 7 tens that are left and 3 hundreds. So I know my missing part is 371. 371. So I should be able to add 371 and 387 and come back to my whole. So let's give that a try. 387 plus 371. 7 ones and 8, or 7 ones and 1 1 is 8 ones. And 8 tens and 7 tens is 15 tens with composing 100. And 3 tens plus 3 tens is 6 tens, plus 1 more 10 gives me 7 tens. And look at that, I am back to my whole, and I see that my whole and my difference match, or my whole and my sum match. So I know that I have done that problem correctly doing my inverse operation of addition. All right, so hopefully this is going really well for you. I'm hoping that it is. Let's go ahead and start by writing our vertical model. 788 take away 299. Wow, I can see that I'm going to have to do some decomposing, but I think I'm going to come over here and at least fill in my number bond as much as I can. I definitely know what my whole is, and I know that one of my parts is going to be 299 because it's right there. I'm just, whoops, you know what I forgot to do? I'm going to come back up here, 371. I'm so sorry, I forgot to put that up there. So I'm going to be looking for what my missing part is. All right, so we need to represent the whole. Let's represent the whole in our chip model, which is 788. Will you count it with me, please? 100, 200, 300, 400, 500, 600, 700. 710, 720, 730, 740, 750, 760, 770, 780, 781, 782, 783, 784, 785, 786, 787, 788. So 788 with 7 hundreds, 8 tens, and 8 ones. So I now have my whole represented, and I can start seeing whether or not I can subtract. I'm looking at 9 ones, taking 9 ones away from 8 ones, or 8 ones take away 9 ones, which I don't have enough. I'm going to have to decompose a 10. Here I go. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now I don't have 8 tens anymore. I now have 7 tens, and instead of having 8 ones, I now have 18 ones. 18 ones take away 9 ones. Well, that's going to be easy. 1, 2, 3, 4, 5, 6, 7, 8, plus 1 more going away gives me 9 ones left, because 18 take away 9 is 9. Now, can I take 9 tens away from 7 tens? Crummy, I can't. I'm going to have to decompose 100. Here we go. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. All right, so now I've got, let me see, I don't have 7 tens anymore. I now have 17 tens. That 10 plus that 7 gives me 17 tens, and I no longer have 7 hundreds. I now have 6 hundreds, but I can certainly subtract. 17 tens take away 9 tens is 8 tens. Oops, wait a second, I better check that out. 1, 2, 3, 4, 5, 6, 7, 8. That leaves me with 8 tens. Oops, I almost goofed that one up. 1, 2, 3, 4, 5, 6, 7, 8. I'm taking away 9. Yeah, that works out right. So 17 tens take away 9 tens is 8 tens. I almost made a boo-boo there. I had to stop and check myself. 1, 2, 3, 4, 5, 6, 7, 8, 9. 17 take away 9, or 17 tens take away 9 tens is 8 tens. And now I have 6 hundreds left because I've decomposed. There it is right there, decompose that. So now I'm going to take away 2 hundreds, 1 and 2. 2 hundreds from 6 hundreds is 4 hundreds. So I have 8 hundreds left, or 8 tens left here, and 4 hundreds left there, which tells me that my missing part is 489. Therefore, 788, take away 299 is 489. And we are now going to be checking this problem using our addition, because I know that if I add these two parts, I'm going to get back to my whole. So I'm going to take 299, and I am going to add 489. There we go. So 9 ones and 9 ones is 8. 9 ones and 9 ones is 18 ones, with regrouping a group into my tens. 18 ones, and I have 9 ones, or 9 tens, and 8 tens is 17 tens. 17 tens plus 1 more gives me 18 tens. That gives me when I did 18 tens, it gave me one group of 100. 18 tens is the same as one group of 100, and 8 ones. 2 hundreds plus 2 400s is 6 hundreds, plus 1 more 100 gives me 7 hundreds, and I can see that I have done this correctly because all the parts of my number bond are now present. So my whole and my whole match, and they also match my number bond. 788, 299, and 489. Congratulations if you are figuring that through. Excellent work. Let's move on to the next page. And we have 2 more problems that we are going to be doing today. So let's start by filling in our number bond. We know that 821 is our whole, and we know one of the parts, which is 523. And so I'm going to set that up in my vertical form. 821 plus 523. And now I need to represent my whole in my chip model. Here we go, count with me. 100, 200, 300, 400, 500, 600, 700, 800. And I've got 2 tens, 810, 820, 821. So 8 hundreds plus 2 tens and 1 1 gives me 821, and I just made a boo-boo here. This is going to be a subtraction problem. Watch that sign, Miss Star. Watch that sign. So I'm going to be taking 523 away from 821, and I'm set up and ready to do that now. So I'm looking in my ones, and I can see that I have to take 3 ones away from 1 1. I cannot do that. I'm going to have to decompose a 10. Here I go to decompose a 10. So that decomposed 10, here we go, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I no longer have 2 10s, I now have 1 10, and I no longer have 1 1, I now have 11 ones. So 11 ones take away 3 ones, 1, 2, 3, leaves me with 5, 6, 7, 8. That would be correct, 8 ones. Now, can I take 2 10s away from 1 10? No, I can't. I'm going to have to decompose 100. Here we go. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So now, instead of having 1 10, I now have 11 10s. Wow, I had 11 ones, and now I have 11 10s. 11 10s, take away 2 10s is 9 10s. If you know your 36s, that would be easy. I am going to take away 1, 2 10s, and that leaves me with 9 10s. Whew. Now, I think I made a boo-boo here. I did remember that I had to decompose one of those hundreds, which now leaves me with 7 hundreds. Boy, that would have been a big boo-boo. I would have had it wrong for sure. So 7 hundreds, now that I have here, taking away 5 hundreds. 1, 2, 3, 4, and 5. That leaves me with 2 hundreds. So I know that my missing part is 298. 298, and my missing part 298. Now I know from my number bond that if I add these two parts together, I should get back my whole. Let's give it a shot and see if that works. One of my parts was 523, one was 298. Here we go. We're going to add those together. 8 ones plus 3 ones is 11 ones. I'm composing a 10. And 9 10s plus 2 10s is 11 10s, plus another 10 gives me 12 10s. And 5 10s plus 2 10s is 7 10s, plus one more 10 is 8 10s. And I can see that my sum and my whole, or my whole and my whole, match each other, and they also match my number bond. Well, congratulations to me. Woohoo, I didn't goof that one up. All right, let's try 913. 913, take away my part, which is 558. There we go. And so I have my whole, take away my part, and I can set up my number bond. Number 913 is my whole, and I know that one of my parts is 558, and I'm trying to find the missing part, which should be pretty easy for me. Let's go ahead and make sure that 913, I'm going to make that not quite so big so I have a little bit more space in case I have to do some decomposing. Yeah, I don't want to make my magnifying glass too big, especially because my space is pretty small. Alrighty, so let's put 913, count with me, 100, 200, 300, 400, 500, 600, 700, 800, 900, 910, 911, 912, 913. Alrighty. Okay, I'm just going to make these just a tiny bit bigger so that I can see those. Okay, so I have 3 ones. Can I take 8 ones from 3 ones? Nope, can't do it, so I'm going to have to decompose a 10. Here it goes. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Alrighty, here we go. So I had to come over to my tens, and I decomposed a 10, which left me with 0 tens. But that 10 is now 10 ones. 10 ones plus 3 ones is 3 ones, and no longer 3 ones. 13 ones take away 8 ones is 5 ones. I'm going to check that out. 1, 2, 3, 4, 5. Oop, wait a minute. Hang on. Wait a second here. Oops, I needed to take away 8. Oh my gosh, I only took away 5. 1, 2, 3, 4, 5, 6, 7, 8. Now that makes much better sense because now I have 5 ones left. Woohoo! I'm on my way. 13 ones take away 8 ones is 5 ones, and I took away 1, 2, 3, 4, 5, 6, 7, 8. Got myself a little bit mixed up there. All right, so now I am coming over to my tens. I've got 5 tens, and I need to take away 5 tens from 0 tens. Holy moly, I can't do that. There's nothing there. I'm going to have to decompose 100. Here I go. That's easy to do. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So now instead of having 0 tens, I now have 10 tens. 10 tens, and I'm going to be careful to take away those 5 tens. Here we go. 1, 2, 3, 4, and 5, which leaves me with 5 tens. Woohoo! That was easy. Okay, wait a minute here. I had to decompose that. Whoops, if you do it in your chip model, you better do it in your vertical model, or you will make a big fat boo-boo, which I just about did. I think I've just about done that twice. I think Miss Star's getting a little bit tired because I've been recording a lot of lessons today. Okay, so we have 8 tens take away 5 tens. 8 tens, let's take those 5 tens away. Here we go. 1, 2, 3, 4, and 1, 2, 3, 4. One more gives me 5. That leaves me with 3 tens. So I have 5 tens, 5 tens, and 3 tens, which tells me that my missing part is 355. 355, which is where I need to put my other part. So 913 take away 558 is 355. Now I can use my number bond to help me check. I'm going to take my 2 parts and see if I add back up to my whole. 335 plus 558 equals, here we go, 5 ones plus 8 ones. 5 ones plus 8 ones is 13 ones. I'm regrouping, composing a 10, and 5 tens plus 3 tens. 5 tens plus 3 tens. Yeah, I just saw my boo-boo. Thanks a lot. I wrote this down wrong. So I am now adding 5 tens plus 5 tens is 10 tens plus 1 more 10 gives me 11 tens. So I'm going to have to show that composed 100. And then I have 3 tens, or 3 hundreds plus 5 hundreds is 8 hundreds plus 1 more 100 gives me 9 hundreds. Boy, I just about goofed that one up. I might need to take a little break here because I'm starting to make little dum-dum mistakes, and that's not making me happy. So I can see that my whole and my whole are exactly the same, and they match my number bond. 300, and did I make the boo-boo over here too? I certainly did. This needs to be 355. That was where I goofed that up, right there in that number bond. Sometimes you do have to go back and double check your work. So I wrote it right up there. I just didn't write it right here. So, yeah, 355 plus 558 gives me 913. Just did not have that quite written correctly. I think I'm going to put this on pause and take a little break. Okay, I'm back. So we're going to complete all of the if and then statements. So you're going to draw your number bond to represent the related facts. So I'm seeing that 762 take away something, take away a part, because here's a part. So this is my whole. So my whole take away a part will equal my other part. Well, I guess I could do that as a subtraction problem. But look over here, I've got my part and my part. My part and my part are going to equal my whole. Well, what is my whole? Well, my whole is 762, and I know one of my parts is 173, so my other part must be 589. So 762, which is my whole, take away 589 will give me my other part, which is 173. That one was pretty easy because all of the parts of my number bond were represented. Now, as I come down to letter B, let's see if all of our parts are represented. So I know that I start with my whole and a part and a part. And then this would be a part, and a part will equal my whole. Well, I know what my whole is. My whole is 631. I know that my whole is 631. And let's see. I know, wait a minute. I've got the same part twice. Well, at least I know what one of them is. 273 is my part. Oh my gosh, I am going to have to set this one up to find out what my missing part is because I don't know. But that's not hard. 631 take away 273 will give me my missing part. So let's just get that going right now. 631 take away 273. Well, this is going to be a piece of cake for me because I am smart and so are you. Can I take 3 ones away from 1 1? Nope, can't do it, so I'm going to have to decompose a 10. That's going to leave me with 2 10s. That decomposed 10 added to the 1 10 I already have gives me 11 10s. 11 10s take away 3 10s is 8 10s. Now I've got to take 7 10s, or that's 8 ones, I'm so sorry. 7 10s from 2 10s. Not going to happen, don't have enough, so I'm going to have to decompose 100. That is leaving me with 5 hundreds. 5 hundreds, and that decomposed 100 is coming over into my 10s, giving me 12 10s. 12 10s take away 7 10s is 5 10s, and 5 hundreds take away 2 hundreds is 3 hundreds. So I know that my missing part is 358, and my other missing part would be 358, which tells me that my missing part here on my number bond is 358. Well, that was definitely a challenge, but we're up to the challenge. Congratulations to you if you were successful with both of those problems. Now, my friends, I know this has been a very long lesson. It is now your turn to do these two problems with each of the parts that we've been working on, and then you're going to send that to your teacher. And I am going to apologize that it was such a long lesson, but there were lots and lots of things that we needed to consider as we were doing lesson number 15. And I wish you a great day of learning.